Sinodonty and Sundadonty, Teeth as Maps of Ancient Migration by AZLAN ADNAN, M.A. Thursday, 25th of December, 2025. Introduction. Sinodonty and Sundadonty are well-established concepts in dental anthropology. Christy G. Turner II formalized them in the late 1980s and early 1990s. He described two statistically distinct patterns of tooth morphology across East and Southeast Asia, extending to populations descended from those regions. Rather than treating teeth as simple tools for chewing, Turner framed them as inherited biological markers. Because dental traits preserve well and are highly heritable, they provide a reliable window into deep population history. Sinodonty, the northern pattern. Sinodonty represents an intensified and morphologically complex dental pattern. It is characteristic of Northeast Asian populations, including Northern Chinese, Koreans, Mongolians, Siberians, and most modern mainland Japanese. This pattern is also strongly expressed in Native American and Inuit populations. Sinodont teeth are morphologically busy, with pronounced shovel-shaped upper incisors, frequent double shoveling, additional roots, enamel extensions, accessory cusps, and complex occlusal wrinkles. Several traits occur at very high frequencies, often exceeding 80%. Sundadonty, the southern pattern. Sundadonty reflects a simpler, more conservative dental configuration. It predominates among Southeast Asian populations, such as Malays, Indonesians, Filipinos, Thai, and many Pacific Island groups. It is also associated with ancient Jomon period Japanese populations before later continental migrations. Sundadont teeth retain traits closer to the ancestral East Eurasian condition, showing reduced shoveling, fewer accessory cusps, simpler root structures, and less crown elaboration. Trait frequencies typically range between 20 and 50%. Key dental traits used in classification. Turner identified 8 dental traits with particularly strong north-south frequency contrasts. 1. Shovel-shaped upper central incisors, UI1. 2. Double shoveling on upper central incisors. 3. Single-rooted upper first premolar, UPM1. 4. Enamel extensions on the upper first molar. 5. Extra cusp on the upper first molar, UM1. 6. Hypocone reduction on UM1. 7. Deflecting wrinkle on the lower first molar, LM1. 8. Lower molar variation, including 3-rooted LM1, Sinodont, and 4-cusped lower second molar, Sundadont. Peg-shaped or congenitally absent third molars also differ between the two patterns. Migration and population history. The Sinodont-Sundadont framework has been central to understanding migration. Native American populations display some of the strongest Sinodont patterns ever documented. This supports an origin in Northeast Asia via Beringia, whether along inland corridors, coastal routes, or both. It rules out a primary Southeast Asian source. In Japan, dental evidence aligns closely with archaeology and genetics. Early Jomon populations were predominantly Sundadont, while later migrations from the Asian mainland introduced Sinodont traits. The resulting modern Japanese dentition reflects this combination. Christy G, Turner II, and other pioneers of dental anthropology. Christy G. Turner II was a professor of anthropology at Arizona State University. He pioneered systematic, large-scale analysis of dental traits across Asia, Siberia, and the Americas. Turner demonstrated that tooth morphology could reveal population relationships invisible in skeletal or cranial measurements. His data sets and statistical methods established dental anthropology as a rigorous tool for studying population history. Other leading figures strengthened the field. G. Richard Scott developed the Arizona State University Dental Anthropology System, now widely used. Scott R. Nickel contributed to trait standardization and cross-regional comparative frameworks. Joel D. Irish extended dental trait analysis into African populations, confirming its global applicability. Together, these scholars anchored dental anthropology within evolutionary biology, genetics, and archaeology. Contemporary use and limitations. Sinodonty and Sundadonty are not rigid categories. There is overlap, regional variation, and gene flow that blur boundaries over time. Some scholars critique the sharpness of the original dichotomy. However, when multiple traits are analyzed together, the statistical signal remains strong. Importantly, ancient DNA now independently supports many migration patterns Turner inferred from teeth alone. As a comparative model grounded in measurable anatomy, the Sinodont-Sundadont distinction continues to offer insight into deep population movements. Human teeth persist as quiet yet durable records of ancient ancestry. The Arizona State University Dental Anthropology System, ASUDAS, by AZLAN ADNAN, MA. Thursday, 25th of December 2025. Introduction. ASUDAS is the gold standard for charting non-metric dental traits, those subtle grooves, ridges, and cusps that hint at shared ancestry. It gives researchers a common framework allowing populations from Cairo to Cusco to be compared without confusion or local shorthand clouding the record. G. Richard Scott. Scott earned both his undergraduate and doctoral degrees at Arizona State University under Turner's mentorship. Later, he became professor emeritus at the University of Alaska Fairbanks and foundation professor at the University of Nevada, Reno. He turned shovel-shaped incisors and Carabelli's cusp into consistent data, tired of journals filled with disconnected descriptions that could not be aligned across studies. Scott helped shape ASUDAS into a set of reference standards detailed enough to be shared across labs. Not perfect, but reliable. An agreed scoring language that made dental anthropology reproducible rather than anecdotal. Christy G. Turner Sickler. Turner earned his PhD at UCLA and spent the majority of his academic career at Arizona State University from 1966 until retirement. He showed that teeth hold their form through famine, heat, and hardship. Enamel does not remodel, and underlying traits stay genetically firm. That stability made dental morphology a key tool for tracking population history before genomic sequencing became routine. Today, ASUDAS remains useful alongside genetic evidence, especially where DNA is absent, fragmentary, or otherwise limited. Development of ASUDAS. Scott and colleagues built a system of illustrated plaques, clear guides that sit beside microscopes and in field labs, from which traits can be ranked: absent, slight, marked, pronounced. The result was a practical vocabulary that researchers could recognize instantly, wherever they worked. These standard reference points reduce disagreement and let datasets connect cleanly across projects. Observer bias still exists, eyes vary, but ASUDAS narrows that margin more effectively than previous approaches. Applications. Archaeologists use ASUDAS to sketch kinship and continuity in places where writing never reached or was never kept. Forensic practitioners draw on dental traits when other biological clues are missing or compromised. In evolutionary research, ASUDAS helps test dispersal models alongside genetic evidence rather than beneath it. Its consistency keeps older studies legible and newer ones comparable. Conclusion. Teeth endure when little else survives. ASUDAS keeps them readable. Turner sketched the terrain. Scott etched the signs. Together, they turned enamel into testimony, and through them, silent jaws keep talking. Learn to cook with confidence. A holiday cooking experience for teens and school leavers. Cooking is one of the most important life skills a young person can develop. We eat every day, and knowing how to prepare good food sets you up for independence, creativity, and lifelong well-being. In my holiday cooking classes, I go far beyond teaching recipes. I blend knife skills with the wonders of food science, the chemistry, biochemistry, and nutrition that shape every flavor, texture, and aroma. It's the practical, delicious side of the science you learn at school. My sessions are fully hands-on. You will feel the warmth rising from a pan, hear onions sizzling into sweetness, smell butter turning nutty and golden, and watch simple ingredients transform into something extraordinary. Cooking becomes a sensory adventure, not a chore. To ensure every student gets dedicated attention, I keep each class small, just 3 to 6 participants. We learn by doing. We taste constantly. We experiment with confidence, and we uncover why small changes in technique make big differences on the plate. Classes are held by appointment throughout the December school holidays. Each session gently builds confidence, skill, and curiosity as students work from raw ingredients to a finished dish they can proudly serve at home. And here's something parents love. My class fees are by donation. If your child walks away bored or unmoved, you pay nothing. But if your child returns home excited, inspired, and perhaps presents you with a classic French onion soup, richly caramelized and impossibly fragrant, then simply contribute what you think that experience is worth. If your child keeps pestering you to bring them back for more classes, well, you'll know you've got your money's worth. All proceeds help fund my ongoing eye treatments, so every contribution goes to good use. Students will also learn how to choose fresh ingredients and shop smart. Do give them some grocery money, because selecting produce confidently is just as important as cooking it well. If you're ready to turn curiosity into skill and skill into joy, I would love to welcome your teen into my kitchen. Parents are most welcome to sit in as chaperones or return at the end to savor their children's culinary creations.